Good morning, Bronx Middle School Math. Today we are continuing with our attributes in geometry. This is lesson 2. Let's begin. The goal for today's lesson is to understand how the shapes all fit together and overlap. You should be able to explain and categorize the shapes based on their common attributes. So, what are the details that they have in common? What are the characteristics that they have in common? Something like, oh, these shapes both have 4 sides. That would be common attributes that can help categorize shapes. Scholars must leave the lesson understanding that a trapezoid is a shape that has 4 sides and at least one pair of parallel sides. First, we're going to review what we learned in lesson 1. So here are some of the questions that we went over yesterday. What are attributes and properties in geometry? What are attributes to a quadrilateral shape? Does the orientation of a shape affect the attributes or classification? Is it possible to have multiple classifications or labels? Pause the video and answer these questions. Make sure you have lots of detail and you draw some pictures to support your answer. Press play when you're ready to continue. All right, let's see if you got the correct answers. So, attributes and properties in geometry are the characteristics that belong to an object and help us classify the shape. So, attributes, like what we said, this is a terrible triangle, but based on the attributes, we know that it's a triangle because it has 1, 2, 3 sides. Now, attributes of the square, again, I don't know what's wrong with my hand today. That's a terrible square. But we know it's a square because it has 4 sides. So it's a quadrilateral because a quadrilateral is any shape that has at least 4 sides. Not at least, excuse me. Quadrilateral is a shape that has 4 sides, exactly 4 sides. And another attribute of this is that it has 4 right angles. Another attribute, all 4 sides are congruent. All 4 sides are equal to each other. So these are some attributes to a square. What are attributes to a quadrilateral shape? Well, we just said a quadrilateral has 4 straight sides. So we know that. It's a flat shape, meaning it's 2-dimensional. We are dealing with flat shapes. We are not doing the fancy 3D pyramid type. No, we aren't doing that. It is your basic flat shapes. And it's a polygon. Remember, a polygon is any shape that has at least 3 sides. So it can be a triangle, square. Give me a second to draw this one. Hexagon, pentagon, octagon. It can be any shape as long as it has 3 sides. But we know a circle is not a polygon because it has no sides. Does the orientation of a shape affect the attributes or classification? No. Remember that the attributes are the same despite the orientation of the shape. The parallel lines, congruent length sides, the number of sides do not change when you rotate a shape. This rectangle is going to be a rectangle and have all the same attributes even if you rotate it to be on its side. It's the same rectangle. We just moved it. Is it possible for a shape to have multiple classifications or labels? Yes. A shape can follow the rules for multiple classifications at the same time. For an example, a square follows a rule for a polygon, quadrilateral, trapezoid, and parallelogram. So let's go over those rules really quickly. So a polygon, the rules for polygon, remember, it must have at least 3 sides. Well, a square meets that because it has 4 sides. So it is a polygon. A quadrilateral is a shape that has 4 sides. Well, a square does have 4 sides, so it is a quadrilateral also. Trapezoid, it must have at least 1 pair of parallel lines. And a square does. A square has at least 1 pair of parallel lines. It actually has 2. And since it does have 2 pairs of parallel lines, that makes it a parallelogram. But remember, this does not mean that the categories are synonymous. Not all parallelograms are rectangles. Not all parallelograms are squares. But all squares are parallelograms. Common attributes. So we're going to share some shapes, give you some shapes, and you're going to list the common attributes that they have. Okay, pause the video and let's list the common attributes that the square and rhombus share. So what do these shapes have in common? It can be the attributes and the labels they have. Pause the video and return when you have your answers. Okay, both of these shapes, the square and the rhombus, are quadrilaterals. They have 4 sides. Both of these shapes are parallelograms because opposite sides are parallel and congruent to each other. All 4 sides are congruent in length. That checks out. Okay, so now I don't want to be a Debbie Downer, but what does the square have that the rhombus doesn't have? Let's list what they don't have in common. So above the shape, I'm going to write, no, I'll do it below. Below the shapes, I'm going to write in purple what they do not have in common. So what do they not have in common? The difference is that a square has right angles. It has 4. A rhombus has acute and obtuse angles. This one would be acute, and this one would be obtuse. Okay, pause the video and list out what do the square and the parallelogram have in common. Start the video when you have your answers. So both the square and parallelogram have 4 sides. We got that. Both are parallelograms because they have 2 pairs of parallel lines. Opposite sides are parallel and congruent. They are not congruent. I'm sorry. Opposite sides are congruent in length. There we go. So opposite sides are parallel and opposite sides are congruent in length. So now, again, we're going to go to the negative. What do these shapes not have in common? So what they do not have in common, so what the square has that the parallelogram does not have, is that the square has right angles. Also, the square, all sides are congruent. All lengths are the same size. With the parallelogram has acute and obtuse angles. These would be acute, and this one would be obtuse. With the parallelogram, has two pairs of congruent lengths. So as you can see, the red lines are equal in length, and the blue lines are equal in length. Unlike the square, all four sides are equal. The parallelogram has two pairs of congruent lengths. So although they have all of these things in common, they still have unique attributes that make them different from each other. But let's also take a second to list the categories that these shapes are in. So what are the common categories that they have? I'm going to list them in the top. So both of these shapes are polygons because they have at least three sides. Check. Both of these shapes are quadrilateral because they have four sides. Both of these shapes are trapezoids because they have at least one pair of parallel lines. And finally, both of these shapes are parallelograms because they have two pairs of parallel lines, where opposite sides are parallel. All right, y'all know the drill. Pause the video and write down what these shapes have in common, and also now you need to also write down what do they not have in common. Start the video when you have your answers. Here we go. So what they have in common is that they all have four sides. They're also both parallelograms. Two pairs of parallel lines. Opposite sides are parallel, and opposite sides are congruent in length. But what's the difference between the parallelogram and the rectangle? So the rectangle has right angles. The parallelogram has acute and obtuse angles. Let's list up here all the categories that these shapes go into. So these shapes go into polygon because they have at least three sides. Y'all know the drill. Quadrilateral because they have four sides. Trapezoid because they both have at least one pair of parallel lines. And finally, they are both parallelograms because they have two pairs of parallel lines. Last one. Okay, now y'all are going to do all of it on your own. Y'all are going to list out what they have in common, and then below the shape, you are going to put what they do not have in common. What are the unique attributes that are different? And then at the top, you need to write down what categories do all these shapes have in common. Ready? Go. Start the video when you have all your answers. We are going to start off with the good stuff. What do they have in common? So the picture on the left, we know as a square. And then the one on the right, trapezoid. This is your classic picture of a trapezoid. But trapezoids can look like many different things. It can come in many different forms. But the only rule it needs to follow is that it has four sides and at least one pair of parallel lines. we can see the parallel lines here are the black lines. And as you can see, the black lines are not congruent in length. They are different lengths, but all that matters is that they are parallel. Okay, so what do the square and trapezoid have in common? Well, they're both quadrilaterals, check. Both follow the rules for trapezoid, meaning they both have at least one pair of parallel lines. And finally, at least one pair of opposite sides that are congruent in length. Notice how these red lines on the trapezoid are congruent in length. And the square has at least one pair of congruent lengths. It actually has two pairs of congruent lengths. Well, if we want to be technical, all four sides are congruent. But yes, it does have at least one pair of congruent lengths. So now I'm going to show what they have unique to each other. Like what's different. So what's different between the square and trapezoid is that the square is a parallelogram. It has two pairs of parallel lines. There's one and there's the second. Also, the square has four right angles. Lastly, with the square, all four sides are congruent. Now, at the top, we're going to list the labels that they have in common. So both the square and trapezoid are polygons. They are both quadrilaterals, and they are both in the trapezoid family. Only the square is a parallelogram. The trapezoid is not a parallelogram. Because as we can see, it only has one pair of parallel lines. To be a parallelogram, you must have two. But remember, a parallelogram can be a trapezoid, but not all trapezoids can be parallelograms. This trapezoid right here, this one, is not a parallelogram. Okay, we are going to play the same game that we did on lesson 1. So one scholar will choose a rule, keep it a secret. They will draw the shape, and after each shape that is drawn, the group will attempt to answer which rule the scholar picked. So the dialogue should look something like this. I'm going to draw a shape. This shape fits my rule. What's my rule? So I give you a square first, and you say, is it that your rule that the shape must be a quadrilateral? No. Here's another shape that fits my rule, and I'm going to draw another shape that fits the rule. So you're going to look at both shapes, and both shapes have to fit the same rule. And then you're going to guess again. Is it that your shape must have at least one right angle? Yes. So we can see that although this square is a quadrilateral, and this triangle obviously has 3 sides, what they have in common is the right angle. So we know that the rule is that the shape must have at least one right angle. Let's start it out. Okay, so these shapes on the left, they follow the rule, but the ones on the right do not follow the rule. Pause the video and write out what you think my rule may be. So let's walk through this. Let's list what the square and the trapezoid have in common. Oh, I need to address something very quickly. This name is the British name for it. But this is just a trapezoid. Okay, So the picture on the right, the kite and the equilateral triangle here, what do they have in common? Well, they are both polygons because they both have at least three sides. So the kite is a quadrilateral, but the triangle is a triangle. But what they have in common is that they are both polygons. Another thing that they have in common is that they both have acute angles. So these would be acute and that would be acute. But that seems to be all they have in common. So we know that those share those characteristics, but now let's go over to the left. And these shapes, the square and trapezoid, those follow the rule that we're trying to figure out. So let's see what they have in common. Well, they're both polygons because they have at least three sides. Check. They're both quadrilaterals because they both have four sides. Check. And they are both trapezoids because they both have at least one pair of parallel lines. Again, the black lines are parallel for the trapezoid, and the square has two actually, but they both have at least one pair of parallel lines, so trapezoid. They are not, only the square is a parallelogram. The trapezoid is not a parallelogram. This trapezoid right here is not a parallelogram because it only has one pair of parallel lines. So we know that can't be the rule that it's following because it doesn't apply to the trapezoid. Well, we know polygon isn't the rule because both of these shapes, the kite and the triangle, are polygons. So we know that can't be the rule. And quadrilateral, well, the kite is a quadrilateral. And it still doesn't follow the rule. See this kite, quadrilateral, and it does not follow the rule. So we know quadrilateral can't be the rule. So it has to be trapezoid. My guess is going to be that the rule is the shape to follow the rule, it must have at least one pair of parallel lines. Let's see if we're correct. And we are. The rule is at least one pair of parallel sides, which is the qualification for a trapezoid. So this definition of a trapezoid must have at least one pair of parallel sides. The shapes on the left follow the rule and can be classified as a trapezoid. Both of these shapes are in the trapezoid family. These shapes, the kite and isosceles triangle, are not in the trapezoid family. All right, next example. So these shapes on the left follow the rule. The shapes on the right do not follow the rule. Pause the video and write down the characteristics and attributes that each of these categories have. So go right down the middle. What do the ones on the left have in common? What do the ones on the right have in common? When you're done and you have an idea of what the rule may be, start the video. Okay, so here's what we got. The pictures on the left versus the pictures on the right. Let's begin with the right. All these pictures, let's figure out what they have in common. So first, let's label them. This is a kite. This picture would be a trapezoid because it has one pair of parallel lines. And in this picture you've seen before, or this shape you've seen before, and it too is a trapezoid. Notice how these are both trapezoids, but they're different. All that matters to be labeled as a trapezoid is that it has at least one pair of parallel sides. So we know that they're both polygons, or all these shapes are polygons, and all these shapes are quadrilaterals because they have at least 4 sides. These are things that cannot be true. So not all of these shapes in this category are trapezoids. The kite is not a trapezoid because look, there are no parallel lines. So the kite is not a trapezoid. And we know the rule that these shapes over here don't follow is that a pair of congruent links. Okay, so look, the kite has 2 pairs of congruent links, and the trapezoid has 1 pair of congruent links. But the trapezoid in the middle right here, it has no congruent links. Look, this is one length, that's another length, that's taller, and that's the longest. Look, they're all different. But the rules that these do follow are that they're polygons and quadrilaterals. These 3 shapes have all that in common. So now let's go over to the ones on the left. What are the attributes that they share? Well, all of these shapes, let's label them first. Rhombus, rectangle, so it's a rhombus, rectangle, and parallelogram. All these shapes are polygons, quadrilaterals, trapezoids, and parallelograms, which means they have 2 pairs of parallel lines, 2 pairs of congruent lengths. So opposite sides are parallel and congruent. So looking at it, we know the rule can't be polygon because all these shapes, the kite, trapezoid, and trapezoid, are polygons. Also, see right here. So we know polygon can't be the rule. We know quadrilateral can't be the rule because all these shapes on the right are also quadrilaterals. So that's not it. And trapezoid? Well, that can't be the rule because there are 2 trapezoids over here. Look. These are trapezoids. So that can't be the rule either. What these shapes over here have that these don't are that they're parallelograms. They have 2 pairs of parallel lines, 2 pairs of congruent links. Opposite sides are parallel and congruent. So there are lots of possible rules here. We have 1, 2, 3 possible rules. Let's see which one it is. And the final rule was, the rule is 2 pairs of parallel sides. That checks out. Parallelograms. This rule follows the definition for a parallelogram. The shapes on the left adhere to this rule and are therefore classified as parallelograms. In this next section, I'm going to be asking some hard thinking questions. You're going to pause the video after I ask you the questions and write down your answers. Think through these problems and make sure that you can explain your reasoning. Make sure you can show me proof. Draw pictures to support your evidence. True or false? So, after reading all these statements, you need to label whether or not the statement is true or false. Write down your reasoning. Be able to tell me why the answer is true or why it is false. Let's go. Pause the video, and when you're ready, press play. All trapezoids are parallelograms. That is false. The rule for a trapezoid is that it has to have at least one pair of parallel sides, but a parallelogram must have two. So in the parallelogram that we saw earlier, it looked something like this. So it has one pair of parallel sides, but a parallelogram has two pairs of parallel sides. So this trapezoid is not a parallelogram. Some trapezoids are parallelograms. This is true. If a quadrilateral shape has two parallel sides, it has at least one pair of parallel sides. So all parallelograms fit the rule for trapezoids. So let's go to our stereotypical basic parallelogram right here. This parallelogram has one pair of parallel sides, two. So because it has at least one, it is a trapezoid. But because it has two, it's a parallelogram. Remember, it could be both. So all parallelograms fit the rule for trapezoids. But as we can see in number 1, not all trapezoids are parallelograms. Like this one, this trapezoid right here is not. It did not have two pairs of parallel lines. Number 3, no trapezoids are parallelograms. False. A shape can be classified as a parallelogram and automatically a trapezoid. So if it's a parallelogram, it's also a trapezoid. And what I mean by that is that if it's in the parallelogram family, it's also in the trapezoid family. Discourse. So again, we're going to be asking some mind-provoking, I want you to be thinking questions. We're going to pause the video. You are going to write out all of your answers. And when you're ready, press play. What makes a shape a parallelogram? What makes a shape a trapezoid? What do these shapes have in common? Is this shape a trapezoid? How do you know? For the last one, you need to write out for each one. So for that hexagon, is it a trapezoid? And then for the trapezoid, square, and kite, is it a trapezoid? Okay, pause the video, and when you're ready and have your answers, press play. What makes a shape a parallelogram? A parallelogram is a quadrilateral. It has 4 sides, and it has 2 pairs of parallel sides. That is your basic parallelogram. You could be a square, a rectangle. I'm sorry, I wish I drew better. But as long as it has 2 pairs of parallel sides, where opposite sides are congruent in length and opposite sides are parallel, it is a parallelogram. What makes a shape a trapezoid? So what is the rule for trapezoid? It must have at least one pair of parallel sides. So it has to have 4 sides. Let's start there. It must be a quadrilateral. And then it must have one pair, at least, never forget that, y'all, at least one pair of parallel sides. So 1, 2, 3, 4, check on quadrilateral. Here's our parallel sides. Check. Trapezoid. Let's go with a rectangle. 1, 2, 3, 4. Check on quadrilateral. These are parallel. These are parallel. So it has two pairs of parallel lines. Check on at least one pair of parallel sides. So this rectangle is a trapezoid. But because it has two pairs, it is also a parallelogram. What do these shapes have in common? So these two shapes, we can see this one is a parallelogram, and then this one is a trapezoid. Both shapes are quadrilaterals and have at least one pair of parallel sides. So both follow the rule for the trapezoid classification. But the shape on the left, the parallelogram, has two pairs of parallel sides. So it's a parallelogram. The trapezoid does not have two pairs of parallel sides. So it is still in the trapezoid section. Is this shape a trapezoid? How do you know? Okay, here's a hexagon. So remember, the rule for a trapezoid is that it's a quadrilateral with at least one pair of parallel sides. Well, these lines are parallel, and these lines are parallel to each other, and these lines are parallel to each other. So it does have at least one pair of parallel lines, but no, it must be a quadrilateral first. Let's go to this one. Is this shape a trapezoid? Yes, because it has four sides. 1, 2, 3, 4. And it has at least one pair of parallel sides. Look at that. Trapezoid. Now let's go to the square. Is this shape a trapezoid? Yes. It has four sides. 1, 2, 3, 4. And it has 1, 2 pairs of parallel lines. Now for the kite. Is this shape a trapezoid? No. This shape does not have any parallel sides. Although it is a quadrilateral, there are no parallel sides. There are no lines going in the same direction that will never touch. A trapezoid has at least one pair of parallel sides, and it must be a quadrilateral. Because look, as we saw here in the hexagon, yes, there are parallel sides, but this shape has 6 sides. It needs to have 4. A parallelogram has 2 pairs, meaning that some trapezoids are parallelograms. All parallelograms are considered trapezoids because they already have at least one pair of parallel sides. Yet, not all trapezoids are considered parallelograms because they might not have 2 pairs of parallel sides. So this square, this quadrilateral fits the rule for parallelogram and trapezoid. This shape right here, this quadrilateral fits the rule for trapezoid, but not parallelogram. And finally, the kite. The one in the middle is a trapezoid. This is a square. And the one on the right is a kite. This quadrilateral does not fit the rule for parallelogram. So we know it cannot be a trapezoid either. So look, in this diagram right here, we can see all parallelograms are considered trapezoids because they already have at least one pair of parallel lines. This is a great photo. So goal. What did we learn today? Scholars should understand that shapes are commonly distinguished by their most specific attribute, but automatically fit into broader categories as well, because they possess the attributes of those shapes too. So this explanation right here, this goal can be displayed in this photo right here. The most specific attribute is that it has two pairs of parallel lines, the parallelogram, but it does fit into the broader category of trapezoid because it does have at least one pair of parallel lines. Okay, so let's read the goal again. Understand that shapes are commonly distinguished by their most specific attributes, but automatically fit into broader categories as well because they possess the attributes of those shapes too. So we can work backwards. So the most specific attribute for this shape is a square because all four sides are congruent, four right angles, but now working backwards, it is a parallelogram because there are two pairs of parallel lines. This square is also a trapezoid because it has at least one pair of parallel lines. It's a quadrilateral because it has four sides. And it's a polygon because it has at least three sides. So its most specific attributes, but it automatically fits into the broader categories. Same with the parallelogram. Its most specific attribute, that it has two pairs of parallel lines, makes it a parallelogram. But it automatically is a trapezoid, which is the broader category. And trapezoids are automatically quadrilaterals because they have four sides. And quadrilaterals are automatically polygons because they have three sides. So the square, it's in the parallelogram family. And because it's in the parallelogram family, it's automatically in the trapezoid family. And because it's in the trapezoid family, it's automatically in the quadrilateral family. And you know, if it's in a quadrilateral family, it will be at the polygon family reunion. Our final goals here were to understand how shapes fit together and overlap. So as we can see, shapes share attributes and classifications. Scholars must be able to explain and categorize shapes on their common attributes. So are all these shapes parallelograms? Are all these shapes quadrilaterals? We need to be able to explain and categorize shapes. And we use the common attributes to do that. Finally, scholars must leave the lesson understanding that a trapezoid is a shape that has four sides and at least one pair of parallel sides. Four sides and at least one pair of parallel sides. All right, y'all. Make sure you do the exit ticket and the homework. Practice makes perfect. Watch this video again if you need more help or explanation, and come to class ready with questions. Have a good day.